And I'm actually not going to start with my traditional introductory slide about how to use the GoToWebinar system. So I guess I'll skip that for today, and I'll ask all of you to send me any comments or questions, especially that you have about using the system if you're not familiar with it. The most important thing to know is that you can use the question panel on the right. If you click the little plus sign to open that up, you'll see that you can type in your questions there. You're all on mute, so you don't have to worry about noise in the background where you are. And to send in those questions, you just type them into the question panel, and it will come to me, and I will kind of look at them every so often to see if there are questions that need to be answered right away or whether they are questions that we can save till the end. Hopefully, if you're having issues, you can hear me, and if you are having issues, go ahead and send me an email, and I'll check my email in a couple minutes to see if anybody has sent me anything. So we're here today to talk about Quantum GIS, or QGIS, and I want to make it clear from the start that this is very much an introductory webinar. I know that some people are coming into this with a fair amount of GIS experience and might prefer to have a little more in-depth introduction to quantum, but I'm assuming there's some people out there who may or may not even be familiar with GIS, so I am going to go fairly slow in terms of explaining what I'm doing and what I'm talking about. And so, again, feel free to send me comments or questions if you want to go a little bit more in depth, and there's time. I'm happy to do that. Not that I know how to do this all that in depth, but like I said, we're going to start out pretty basic. So before I even get to QGIS, I want to very briefly give you a quick tour of our website, not the whole website, but the part that pertains to QGIS training. If you look over here on the left, we have a button that says Education and Training. If you click on that, you'll see VCGI training opportunities below that. And I just want to point out, so this is in reference to trainings that happened last summer. This will get updated as we get closer to next summer. The important thing is down at the bottom of this page, you see 2013 materials. So these are the materials that I used in a training that focused on using using QGIS. That's chapters 1 through 8. And then there was a second training that actually did focus on ArcGIS, and there's just one link below that says Intro to ArcGIS Manual. One of the reasons I want to point this out is that what we are going to do today is basically Chapter 3, Introduction to Quantum Projects, Data Layers, and the Map View. So if you'd like, you can download that document, and that's pretty much what I'm going to be doing. So either now or after the webinar, you can look at that as additional materials to review what we're doing today. Okay, no questions so far. So I just wanted to point that out to you. I think if there's anything else. Oh, I want to mention the fact that since we are going to be using data, obviously we're going to be bringing in some data that originally came from the VCGI website. If we have time at the end, I will come back to the website and spend a little bit of time on how you find that data. Again, for those of you who are not that familiar with our website or getting Vermont GIS data, that's not the focus of this webinar, and I'll actually point out, that was the other thing I was going to point out, that next week I have another webinar scheduled that's called Quantum GIS Data Acquisition and Transformation, and this webinar gets into a little bit more detail on how, first of all, how you find data, mostly focused on finding Vermont data at our website, but not exclusively, and then how you deal with various types of data and formats, and how some you can transform, some you can pull in directly. So if you're interested in that kind of stuff, that's happening next week. All right, I think that I will now go open up QGIS. So Quantum GIS, or QGIS, is free and open source software. And for anyone who's not familiar with either of those terms, they're not the same thing, which is one thing to keep in mind. We all know what free means. Open source refers to the fact that the code that is behind this software is actually open and available to anyone. It's not proprietary in the sense that most software is. And that means that there's a whole community of people out there who are interested and able to take that code and basically evolve the software and contribute that back to the community if they choose to. So that's open source, and the fact that it's free obviously is very convenient because it means we just go to the website. Let me just quickly take you there. You can literally just go to the website and access the newest version of QGIS right here. As you can see, there's actually a newer version than the version I'm going to be using today, which I have not had a chance to download, and it's going from 1.8 to version 2. Actually, it looks like they're already on 2.0.1, and that was enough of a change that I haven't had time to get to that. All right, so here's QGIS. As you saw, we open it up. Looks pretty similar to many GIS software programs if you do have any experience with them. As we get, again, for those of you who are not that familiar with GIS, I'll be trying to explain some of the aspects of this as we actually encounter them rather than doing stuff ahead of time, because the types of data, we're going to use that type of thing. But right now, let's just do a very, very brief tour of what we're looking at. Over on the left, where it says the word layers, we often refer to this as a table of contents, the list of data layers. It's where we're going to see our data named and listed as we add it to our project. We're actually going to see the map being drawn over in the bigger area on the right. All across the top, of course, we see lots of icons that do a lot of different things. Many of them turn our cursor into a variety of different types of tools. And then some of them actually make something happen or allow us to add data in the case of these. Oh, and I should pause as I move my cursor around so that you can see that when you hover over a tool or an icon, generally it will give you a quick name or description to explain what it is. And then, of course, there are menus up here that you can open up to do various things. And actually, the very first thing we're going to do, because I'm right now opening a brand new blank project, so I'm starting from scratch. I've opened up the software. This is like when you open up Word and you're going to start a new document. You've got a blank document in front of you. In a map, in particular in QGIS, at least in version 1.8, it's important, I have found, to set your coordinate reference system. So before you get started in adding data, what this refers to is the system that is used to describe where things are on the Earth. Most people are familiar with latitude and longitude, which is actually, if you look at what's highlighted in blue here, is referred to as WGS 84. That's actually the latitude-longitude system. There are also state plane coordinate systems that are more commonly used within when you're just looking at state data within a singular state or a couple of states. So, not surprisingly in our case, and the reason those are already listed up there is because I've used this program before and it's remembered other the various coordinate systems that I've used. If you were starting from scratch and nothing was up here because you just were using it for the first time, you could use this filter feature up at the top and type in Vermont, and down here in the bottom, or not quite the bottom, but down here where it says Coordinate Reference Systems of the World, we see the hits that it finds based on what I'm searching for. So I'm searching for Vermont. I see a few different versions. I happen to know that what I want is the most recent datum, which is NAD, is North American Datum, 1983, Vermont. And notice that when I highlight it, if you look down here, this is actually the information that's being transmitted to the software about what this means. And one of the interesting things I might point out is towards the end here it says units equal M. That actually refers to the fact that our coordinate system, our state coordinate system, is measured in meters. Just means that that is the unit of the measurement when we measure from a 0, point to wherever we're talking about within the state. So the important thing here is just that it's a good idea always to set your coordinate reference system before you start adding data. You have to click here to enable on the fly. On the fly CRS transformation, and then we pick NAD 83 Vermont, and then we say OK. And actually, let me open that up one more time. notice that there's this little code, EPSG code 32145. If you write that down somewhere, that's a useful code to know, because you can also search on that and you'll see that that comes up. And the other nice thing about that is if you remember it, if you now look down in the right-hand corner of our screen, just below the map, you'll see EPSG 32145. So that's just reassuring to me that we really have set it to the proper, coordinate system. Let me just glance at my questions here. Someone's pointing out that the new version of QGIS is quite different, so I guess I'll have to do an updated version of this maybe later this year when I have a chance to actually look at it. Sorry, one more question here to look at. Yes, I believe somebody asked about whether we can set UTM zone as well, and I believe that we can. Actually, let's just put, yeah, there's UTM zones in there as well. So almost everything is in here. I actually found it interesting that for Vermont, they do not give an option to do our coordinate system in feet with the meters, with the units being feet, whereas New Hampshire they do. So New Hampshire, you can see here's the version that if we look down where it says units, it's meters. And here's the version that obviously it's feet. It says feet in the title. So most everything you'll find in there, but not guaranteed you will find everything. So it's a good question. But there is UTM. There are UTM options. Okay. So we have set our coordinate reference system, and we are going to add some data. So the basic idea with GIS is that we are adding data layers. Each, if you imagine a map and really pull it apart, it consists of many data layers. Up here in our toolbar, one of the slightly annoying, in my opinion, differences between QGIS and ArcGIS is that there are actually different buttons depending on what type of data you're going to add. So this button, just hover over that again, is the Add Vector layer. The next button is the Add Raster layer, which means you need to know the difference between vector data and raster data. So let's actually go ahead and add it and talk about what that means briefly. So this just automatically went to a folder that I have been to a lot, and most recently on my hard drive. So the path here, as you can see up above, is C Intro GIS Data. This is the folder that I use for training I do during the summer. And there's my data. So this format is called a shape file, and you can see that the extension is .shp. This is boundary underscore TWNBNDS, which means town boundaries. So I click Add. Oh, and I forgot to point out that we can ignore all this up here. Since we're just adding shape files, we're adding a file. We're not going to worry about setting or changing anything up here. And we'll just click on Open to add it. There, so now I've made a map. So this is referred to as vector data because it is a data format that the software actually interprets and draws. So vector data is essentially drawn by the software. And the information that is contained in it has to do with the coordinates and the fact that in this case it's polygon data, meaning each of these towns is a separate feature. Each one is an area or a polygon, and then they all happen to fit together like a puzzle. Let's add another type of vector data from the same place. This time we're going to add line data. So we're going to add some roads. Transportation, RDS, MAJ1 means major roads. For some reason the default colors on this are nice and dark. So ignore the fact that I'm about to change these because we're not really going to talk about this today, but just pick some lighter colors. Maybe just something that stands out. It's going to look kind of awful, but we'll be able to see it. So this is line data. obviously not obviously, but in this case the roads are being represented by lines, and so the information that the software is interpreting is just, this line exists at these coordinates going in this direction, connecting to that next coordinate, and from that information it can draw it. And the location of those coordinates on the Earth, the fact that that is actually inherent to the data, is why it can just automatically line up the town boundary data underneath and the roads data on top. So we'll add one more layer, and I'll just point out there are a few different ways to add layers. I tend to use the button right there because it's in front of my face, but you can also click on the layer menu and you'll see that you have all these add data options, the same as what's on the menu listed here. So one more vector layer. This time we're going to add the facilities, PTS school. So these are the school points. And the reason it's points is because they are points. So we have points, lines, and polygons, all the 3 different types of vector data represented on our map. And I think everybody knows what a point is. So vector data, points, lines, and polygons, it's allowing the software to draw the data. And as you saw me quickly do, one of the benefits of vector data is that you can very easily change how it is symbolized, because the software is drawing it. So we get to decide what color it is, how thick it is. In the case of polygons, we get to decide both an outer edge color or a outline color and the fill color, whether there's fill or not. All of those are decisions that we get to make as map makers. The other type of data that we can add, or that we're going to add today, is called raster data. And raster data just means that rather than being information that the software really has to interpret and draw, it's really just a picture composed of pixels that also has the locational coordinate information as part of it as well. So let me just highlight these 4 orthophotos. So these are aerial photos, and I don't know if everyone saw that, but they came in right about here, and I'm just going to zoom in on this spot on the map. So this is Randolph. I originally put these together to show the VTC campus, which unfortunately goes across 4 different orthos. So here's the Vermont Technical College campus in Randolph. And so we all know what a photo is, right? We all know that as you zoom in on a photo, eventually it starts to do this. It starts to pixelate into the dots, or in this case the squares or cells of which it is actually composed. It's always composed of this collection of gray and black and white points. But when we zoom out, our brains are able to put those all together and interpret them in a way that's much more meaningful than when we zoom in too much. So raster data is composed of all these points, and any particular raster image, every single cell in that image has some value. It, in this case, is a black and white ortho, so it's a value that's somewhere between white and black and a bunch of grays in between. A color image would have, obviously each cell would have some color value, and you put them all together and you end up with a picture. Remember that with vector data, the data is only going to be shown where there are coordinates that were indicated in the data. So let me just show one of the other key things about GIS in general, which is that you can have all your nice data layers here listed over on the left. We can also just turn them right off and only look at a few things if we want to. So now these are all still part of my project, but I'm not having the software visually represent them. So we're just looking at the roads data. And notice that this is not an image that has a bunch of cells that are white, 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 blue, white, 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 blue. This data is only being represented where it actually exists, where the roads themselves are. Everything else is actually blank, which is why when we turn something on that's behind it, we can see it. The only place it's blocking is where the roads actually lay. On the other hand, when we turn on this raster data, notice that it's actually on top of our other data layers, and therefore it just covers them right up. The nice thing about being in a digital environment with GIS is that we can change that. We can move our roads data on top of the orthophoto so that we can see it. We can make sure our school points data is on top so that VTC shows up. If we cared about our town boundaries, we could put them on top, but notice that as soon as I put them on top here, they're actually blocking everything out because they're being represented right now with a solid color. And so another important thing that's happening here is that the software is going to draw these different things that I have put into the project and that are listed in this table of contents. It will actually draw them in the order in which they appear listed, and luckily I can change that very quickly and easily. Let's see. Okay, so I pointed out that we can turn things on and off. We can change the order of the layers. Notice that what I did to move those layers around was simply highlight a layer, hold my left mouse button down, and drag the layer. So that's how I'm achieving that. Just going to see. No. All right, so that's how we move the layer, change the layer order. Once we've added data layers, we can also remove them very easily. Obviously, you can visually turn them off by just turning them off, but occasionally when you've been working on a map for a while, you pulled in a lot of different layers, you may have actually created layers from other layers, you realize you've got things all cluttered up over here, that you actually have stuff that you don't need. And to remove a layer, you simply highlight it, which is just a single left click, and then right click. And notice, as you may have seen before, when I right click on a highlighted data layer, it actually opens up this new menu that's called a context menu, meaning it's specific to the thing that I've clicked on, in this case the town boundary layer. We've got options like zoom to layer extent, so that'll zoom me right back out so that I can see all of that particular layer. And notice that when I do that on the orthophoto, it zooms me right into that particular orthophoto. But I can also remove the data layer here. So just get rid of it. So let me talk for just a second about what that means, that I've added data and I've removed data and I've changed the color of a few of the data layers, as you saw, even though we're not going to talk about how I did that. When I do those sorts of activities, I'm not actually changing the data in any way. What I'm doing, I'm not making a copy of the data and putting it into this project. I'm not changing some aspect of the data to give it these different colors. All I'm doing is changing some information that's within this project. So this particular map project is going to remember for me when I save it, which I could do right now. What saving this project means is I'm saving the information about which data layers I wanted to include in it, and what it's really remembering about these data layers is where they are currently located. So if I right-click and go into the properties for this particular data layer, and I go over to the General tab, or actually, is that where it is? Oh, I've gone to the wrong place. No, I guess it's not in here. Sorry, I thought I could point out where this data is actually located in here. So what it's going to remember is that this trans road major 1 underscore line is located in, as you see when I hover over it, actually C intro GIS data trans RDS major 1 underscore line dot shape. So it's actually remembering where the data is as well as what it's called. What that means is if I were to move this data to a different folder and then come back and try to open up this project, it would just give me an angry little something, an X or an exclamation point or question mark to say, I don't know where this data is. You told me it was here and I'm looking for it here and it's not here anymore, so I can't draw it for you. So that's an important thing to remember. when you indicate a data layer to include in your project, you're essentially saving a reference to where it's located. If you move it, you're going to have to reestablish that connection the next time you go back to your project. But it also means you can include this data in a million different projects. You're not actually creating copies. You're not wasting space. You're not directly affecting the data by simply bringing it into the project. And the same thing is true about the symbology. The information about what color this line is and how thick it is all just within this project. It's not actually attached to the data itself. Only within the project is it connected with the data. Okay. So what I just did was save a project. One of the other things that people who are new to this occasionally get confused by is the idea of the project and the data. So keep in mind that we're bringing in data layers. We clicked on our Add Data buttons to bring in the data, and we're saving a project. Let me just see if there's anything else I want to know. So to illustrate that, I'm now going to leave this project and open a different project. So initially, remember, we just opened this up, blank, added data. Now we've got a project. It's named, doesn't say it up here, does it? Oh, yeah, it is. QGIS Webinar is what I named it. So once I named it, that does appear up here. But now I'm going to click on a button that says Open Project. So this is opening an already existing project. So there's my saved version of this. But now I'm going to open a new one. And because it's an older version, it's giving me a little warning. Now you'll notice that it didn't say anything about that other project as we closed it, and that was actually because I had already saved it. If I hadn't saved it yet, or if I'd made a change since I saved it, it would have asked me if I wanted to save that change or if I just wanted to discard any changes. But because I had already saved it, it didn't bother to ask me that. So here, what I've done is open an existing project. So this project already had been created and has these references to data layers. Almost the same data layers as the last one, except that we've now got airports instead of school points. All right, so I've done a little bit of this, but we're going to do a little bit more just to illustrate these various tools that we have up in the toolbar. Many of you are familiar with zoom in a little bit, with idea of pan, this hand that allows you to kind of drag the map around just like you do in Google Earth or Google Maps. Keep in mind that in a GIS program, generally you need to make sure you've actually turned your cursor into a pan tool in order to use that, because your cursor can be a bunch of other tools as well. So a zoom in tool allows you to either just do a single click and it will zoom in a predetermined amount. Same with the zoom out. I'm just left single click on the map and it zooms out. The other nice thing about the zoom in tool is that you can zoom into a very specific area. So I can zoom in to this exciting school, or rather airport, by just drawing a box. And I'm drawing that box by pushing down on my left mouse button in my case, upper left corner of the box that I'm going to draw, holding that button down and then just dragging my cursor to the the bottom right corner of my box. So because I'm right-handed, I think up in terms of starting in my upper left and ending in my lower right. You can obviously go whichever way you want, and you can make the box whatever size or shape you want, but keep in mind that you're always going to be looking at an area that is bounded by this window here. Let's see, we've also got zoom full, which just means zoom to full extent. So whatever the layer is that has the biggest extent, it will zoom to that extent, so everything's in there. We're not dealing with selection right now, but both of these have to do with either panning or zooming to a selection. Zoom last can be helpful if you accidentally zoomed in way too far and have no idea where you are, or if you zoomed way out without really meaning to, you can zoom back into whatever your previous extent was. So I've used the word extent a few times. Probably you can figure out what that means, but it's an important concept when you're working in maps. Right now we're at full extent. We're kind of at a statewide extent. There are a number of different ways to describe your extent, your scale also. Your extent technically is defined by the coordinates of the corners of whatever you're looking at, or the coordinates of the boundary of whatever you're looking at. And in this case, the coordinates would be measured in Vermont state plane meters. And actually look down at the bottom of the screen, and you should be able to see that as I move my cursor around, those little numbers, two big numbers with a comma in between, are changing, and those are actually the coordinates in meters. So if I hold my cursor here, the point that I am indicating at the center of my little zoom in tool is 489,045 meters to the east and 196,867 meters to the north from the 0, point that is set in the Vermont State Plane Coordinate System. And that 0, point exists somewhere over in New York State. So everything in Vermont can be measured from that point as a certain number of meters to the east and a certain number of meters to the north. And that will designate the point. You also see down at the bottom, just to the right of the word scale, the scale of our map. So right now we are at a scale that is described in a how do I say this wrong? A representative fraction. Oh, let me say the wrong term. Representative fraction. So this representative fraction is 1 to something generally. You'll notice that it does not actually have, well, you may not realize this because this doesn't have units associated with it either, but a representative fraction specifically does not have units associated with it because you can express it in any units. They just have to be the same on both sides. So in this case, 1 to 257,481 means if I were to measure 1 inch on my computer screen, that would be equivalent to 257,481 inches in real life. So that's the scale of this map. And obviously you can do the calculations to figure out how many miles that might be. And the reason that that type of scale is used on this is because that way it is unit free, and you can assign whatever units you want to it to make it more meaningful to you. But generally, as you get familiar with scale, you realize that a statewide scale on a computer screen at least tends to be 1 to 1.2 million in this case. I have a medium-sized screen, not a big one. And that, a town-wide scale might be more appropriate, 1 to 80,000, something like that. Anything else about scale down there? I don't think so. Oh, the other thing I was going to point out is that if you click on this little drop-down arrow just to the right of the scale, the fraction, you'll see that you can choose from among some set standard scales, so that if you particularly want to look at a scale, which in this case is not that interesting, let's go to a bigger one, a scale of 1 to 250,000, say, you can get right there by just choosing that. You can also, if you need to be at a very specific scale, you can actually type it in. So maybe I want to be at a scale of 1 to 325,000. And notice that I don't actually have to type in the 1. I just have to type in the 325,000 and then hit enter, and now I'm at that scale. I'll just throw out there, because it took me years to learn this, that the terms large scale and small scale tend to be the opposite of what we think they might mean. Large scale actually means zoomed in, and small scale refers to zoomed out. And the way that you can think of that, if you actually think of this as a fraction, so think about 1/2 as compared to 1/4. So the number 4 in the 1 to 4 fraction, number 4 is bigger than the number 2, but actually what that means is that you're dividing up your whole into more pieces, which means each piece is smaller. So 1/4 is actually smaller than 1/2, even though the 4 is bigger than the 2. So if you sort of think of it that way, the large and small scale thing makes sense on maps. Let's see. Yes, the other thing, and I'll point out that having the scale work properly and indicate to you the true scale, the reason that that's working for us is because this particular project already had the coordinate reference system set properly before we started. So as you can see, it's set to NAD 83. But that's one of the reasons that we did set our coordinate reference system on the other project right away before we got started, because the software doesn't necessarily know, or in some cases it does. ArcGIS does, and QGIS, I'm not sure whether it automatically actually sets your coordinate reference system for you when you pull in data. My experience has been that it does not, however. And what that means is it doesn't know what the scale is, because if it doesn't know what the units of your coordinate system are, it can't figure out the scale. So by setting all of that ahead of time, we allow it to do the math for us and figure out the scale so that we can take advantage of that. And the other thing it allows us to do is measure. So if we go up here and find the measure tool, which looks a little bit like a blue ruler and a blue blob above it, because we can measure both line and area and angle, as it turns out. So if I wanted to measure maybe the area of a town, I can turn that on, and then I just start clicking. So I'm clicking at each vertex where I want to sort of change directions. Obviously this is only going to be approximate. And then I do a double click at the end. Whoops, I think I can do a double click at the end. Or I can just say, oh, come on. There, sorry. Right click at the end to get it to know that I'm done. And there's my measurement, which unfortunately, I'm hoping that QGIS version 2 has improved this, but it does automatically and seemingly without the ability to change this. It does your measurement in the same units as your coordinate system. So in this case, it's metric. There is a place where you can change what it measures in, but I think it would make a lot more sense if we could just change it here because it's just math and it should be able to do that. But it does give us the area in kilometers squared, and we can obviously do the math to figure out acres or square miles or whatever we might be interested in. And the line tool works the same way. We could draw a path down a road, and then when we're done, we do right click, and it tells us both the legs where I've clicked and the total, the length of the legs as well as the total. Okay, I'm going to pause here and ask if people have any questions about the basic functionality of the software. As I said, this is a very introductory webinar, so my goal was just to get us in here, show how it's set up, how we bring data in, maybe a little bit of understanding of the data if you're not familiar with GIS data, just a very little bit, and introduce you to that basic functionality of just moving around, zooming in and out, turning layers on and off. So we do have plenty of time, though, as I suspected we probably would. If people have questions about anything in particular, all right, let me look at my questions because I think I do have one or two here. Okay, oh, I'm sorry, somebody else asked what is UTM back when I was mumbling about UTM because someone had asked a question about UTM. UTM stands for Universal Transverse Mercator, I think. It's a particular worldwide coordinate system. And most people have heard of it because you'll see it on maps. You'll see it on, I guess, USGS maps refer to UTM zones. The zones are geographic, so different zones, areas of the country are in different UTM zones. Vermont, I believe, is zones either 17 and 18 or 18 and 19. Okay, so somebody asks, any tips for identifying coordinate system of your data source? Unfortunately, really the only way to know the coordinate system of your data source is to know, which means hopefully the person who gave it to you knows, so you can go back to them and ask them if they didn't initially tell you that. Obviously, you could try to figure it out by logic. If someone from New Hampshire gave you data, hopefully it's in New Hampshire state plain feet. Or, yes, thank you, look at the metadata. If your data came with metadata, and actually we're going to talk about metadata in just a second, so I will show that. So the most important thing actually is that when someone gives you data, you should ask them as many questions as you can about it, especially if it does not come with an additional file called metadata. And the coordinate system would be one of the things you need to know. The webinar I'm doing next week, I'll talk about how you actually deal with data that's coming in different coordinate systems, because as you saw, we are setting the coordinate system of this project, and one of the benefits of that is that the software will actually transform things that are in different coordinate systems if it knows what they are. So the other thing I was going to say is really the only way you can know is by asking your source, whoever's giving you the data. The other things you can always try are just some of the standards like UTM or WGS, WGS being latitude, longitude. If you look at your data and it looks like latitude, longitude, you might be able to get lucky. Okay. All right, we'll talk about metadata in just a second. Somebody's asking about whether there are analysis plugins such as ViewShed. Yes, there definitely are. Now, I'm not going to go into them today, partly because I have not used most of them. I'll mention that when you install QGIS, you do actually have a set of standard plugins that come with it, but are not necessarily turned on when you first open it up. So you would just click on that plugins menu, go into manage plugins, and you'll see this list. And you can see that I've turned some on. Some actually I think were already turned on. So there are some in here that you can check out. The other thing about having, well, this is true for most software, but having open source software is that you can just start Googling whatever it is you're looking for, QGIS and ViewShed analysis, QGIS and whatever else, and you will find, excuse me, you will find lots of references. If something exists, you'll find it, and you'll find people talking about it and talking about using it. And there's a very, very active community of people out there using the software, but also talking about it online, and they tend to be very responsive also to questions. So looking for additional analysis tools, I would definitely recommend that you just Google stuff and see what you find. And actually right on the QGIS website, I believe there are forums and stuff where you can look for things. So somebody asks about more advanced topics. So yes, you may have missed at the beginning, I pointed out that, let me just go back here to our website. Next week I'm doing a slightly, not terribly, but slightly more advanced webinar just about how to deal with different types of data, different coordinate systems of data, tabular data, GPS data, how you bring in different types of data into Quantum. I have to be honest, I personally haven't done a lot of advanced things with QGIS. Mostly what I use it for is to teach other people how to do basic things and then just to make simple maps. So if people are interested in more advanced topics, I can certainly try to find someone who's using QGIS in more advanced ways to do a webinar on something, especially if you give me some specific ideas about what you're interested in. When we finish the webinar today, you'll have a chance to do a little feedback form, and it would be great if you give me feedback on what specific topics you might like to see in the future, or just send me an email at any time. I'll point out that my email is right here on our webpage over on the left. Just hover over my name. Okay. I am going to talk briefly about metadata now, because the question about answering questions about data is really important. Like, just what do you know about your data and what do you need to know about your data? So I'm going to, I guess I'm also going to very briefly show you how to access data at VCGI. So as you saw, if you come to our website and click on the Data and Imagery button over on the left, it both opens up some other subdirectories, but it also goes right to this Search Tools page. And I'll point out that these two things are not connected. They're two totally different ways of searching. One is by category or theme. The other is just by typing in a keyword. So I know that we have airport data, so I'm going to go ahead and type in airports. And no matter how you search, you get a search results table that has either one or more results. You get the actual name of the data layer, very brief description, who the data owner is, and you'll notice that just about all of the data on our website, it's not VCGI. It all pretty much comes from other sources. We are just the data warehouse. We make it available. There's a download button. So if I wanted the airports, I would just click on this, I would get a zip file that has a shape file within it. Also didn't point out that shapefile really is composed of several files, which is part of the reason that it's zipped up. We can look at that in just a second. And I would just save it somewhere on my hard drive where I knew I could find it later. You need to be able to navigate to it later and know the full path in order to get back to it from within GIS software. But let's just say instead of actually downloading the data, I have questions about the data. I want to know, well, how old is this airport data, and should I assume it's 100% accurate, and what does all the information in there really mean? So if I click on more info, I get a little bit of information, like the age of the data and when it was posted on our website. I get a direct email link to the data manager, so if I have more questions, I know I can ask him. Gives me an idea of the scale at which it's meant to be used, which is what source map refers to, which is a really important thing to know about your data. Often people will complain about data not being accurate. Well, the issue is not actually that it's accurate, it's that you're zoomed in too close. And it was never meant to be accurate at that zoom level, that scale. So that's always a good thing to glance at. I can see here that it's statewide, that it's point data. But the key thing here is this link to the full metadata. So metadata, which hopefully everyone's heard of because it was in the news with the whole NSA thing. Metadata really just means information about the data. So here is a bunch of slightly difficult to look at, very detailed information, and we can open up these different parts to read a description, which is nice, that's in English, and a whole bunch of other information about the data. Data quality might be nice to know. Verified against the VTrans Airport Inventory Database, that's nice. Basically is telling us that 1 to 24,000 USGS base maps, it's about the same as that in terms of accuracy. We didn't get into attributes, but I will point out that if you're curious about what information is connected to the data you're looking at, besides just this is where an airport is, there is actually a lot more information in many cases. Each airport in this case has these different attributes associated with it that include things like the name of the manager of the airport, the address, a phone number. And remember, this is 2004 data, so it may not be terribly up to date. We also have a really convenient one called miscellaneous, or MISC, which actually gives us very important information, the type of ownership. In this case, it's whether it's municipal, state, or private. So this might be where we go to find things like, I think it says up here, no, where's your question about, let's see, coordinate system, there we go. So a horizontal coordinate system is where we see state plane coordinate system, still kind of cryptic, unfortunately. 4400 refers to the Vermont, or no, actually that maybe refers to a USGS code. Well, we're in Vermont, so I guess state plane coordinate system is considered to be enough. All right, let me find some other questions here. Can you measure the distance along a road between town intersections? I assume that's, two intersections. Yes. Okay, so we have a question about using the measure tool. And I believe he's getting at the segment length. So yes, if you wanted to manually measure, say between this intersection and this intersection, you can see that it would not be very easy, and it's not a tool like I think Google might have now that kind of automatically follows a line. It's much more manual. Oh, that's convenient. It's basically when I click is how I keep my measurement along my road. So it's definitely, the more you zoom in and the more careful you are, the better it's going to be, but it's not perfect. And there are probably easier ways to figure out the length of this segment, to be honest, but if you just wanted to do a quick and dirty manual measurement of something like the distance between two intersections, you definitely can do that. And remember that in order to stop the measuring, I have to right-click, and then it will total up and be done. anything else? I could mention one other, since I've shown you vector data and raster data, I could also mention something, one other way to get data in your map. So as you saw, we can search for data. We can use the search tools. If you go in here and look around a little bit, so pick a theme and click, what you'll find is there's a lot of data. We have a lot of data in Vermont. We're very lucky. Not all of it is completely up to date. It varies in terms of both age and accuracy. It is always a good idea to take a look at that More Info button to understand your data before you start using it, but there is a lot of data. And all of this data that you find in here is data that you're going to download onto your computer and then access it in the software from your computer. Another option that is available is what we call web services. We're not going to talk about geocoding services right now, but imagery and map services are basically ways to deliver that map information over the internet. So in order to do this, you have to have a live internet connection, and you have to have a pretty good internet connection. I wouldn't do this with a very slow internet connection. So I'm in the imagery services list, and you can see that we have best of black and white imagery, best, let's see, black and white, black and white, black and white, best of color infrared imagery, and best of color imagery. And then we also have some specific subsets, just the 2011-2012 imagery, which is the newest vintage of imagery. And then also just the 2012. Not sure why we have both 2011, 12, and just 12. Oh, they're together and they're broken out both. So let's say I wanted to see what the Color Vermont Orthos, let me just see what my options are here. Oh, those are not cached. And I'm not going to bother to explain what caching is today. But let's say I do Color Vermont Orthos 2011 and 12. So what I need to do, as you can see, this second little bullet says URL for ArcGIS version 9.3 and open source. Remember that I said that QGIS is open source. That is the key thing here. So I'm going to copy this almost complete URL. It's not quite complete. I'm going to go up here to my Add Data buttons, and I'm going to find the one that looks like a little world, and it says Add WMS Layer. And just to, whoops, remind you, this is Web Map Services. So Web Services, Map Services. So that WMS is referring to Web Map Services. In order to add this service, I have to click on New. I'm going to paste that URL that I copied in here, and before I go away from that, I'm going to add my HTTP :// so that now it's a full URL. I'm going to call it Color 2011 and 12. I don't need a username or password because this is not password protected. Now that it's there, and see it's very subtly listed here, I actually have to connect to it. Oh, come on. I'll try a different one. I've done this successfully many times, so it should work. Best of black and white. Let's try that. Okay, so now let's try that one. There it is. I don't know why the other one didn't work. All right, so if it works, obviously nothing much happens except that it appears down here. I'm going to highlight it. I'm going to give it a better name than 0. And I'm going to add it. So what I just did is add black and white imagery for the entire state. And just to let you know, if I had tried to do that tile by tile, remember we had our 4 tiles in our previous project. If I had tried to do this tile by tile, it would have taken me a lot longer than the few minutes that I had left in the webinar. So by doing this, it also, you can see that it draws really quickly when we're at statewide because it's not trying to give us all the detail. But yet if we zoom in a little bit to a small area, it's going to take a minute, it actually draws, oh look, there's my office. It draws pretty darn quick, and you can quickly get the much better resolution as you zoom in. Just open up the questions. Okay. So I know that for those of you who are not that familiar with that, that might have seemed a little bit too quick to mention, but I just sort of throw it in there so that if you're interested in that, you can always contact me to kind of run through that again. It is also in next week's webinar, and it's in the handout, the Chapter 4 materials, which is what I'll be using next week for that webinar. If we go back to my web page here. So at the VCGI web page, for anyone who missed that, Education and Training, VCGI Training Opportunities, down at the bottom of the page, there are chapters that were used during a training that I do during the summer. And today we've been doing Introduction to Quantum, Projects, Data Layers, Map View. And so that can serve as a review if you want to go back and do all this on your own. Pretty much everything I did is in there, except for what I just did, which is really from Chapter 6. And that's just adding the web map services. Just another way to add data. Accessing data via web map service. So if you're interested in that, you can either check that out or just send me an email and ask me how we did that again. So once again, if anybody has any questions, we've got a little bit more time to answer them. And if not, I'll probably sign off in a minute or so. And as I said, and I forgot to mention something else, so when you sign out, you will be given the opportunity to do a feedback form, just 3 little questions. Really appreciate it if you answer them, and especially looking for input on future webinars, how this one could have been better, all of that information. I'll also mention that this is being recorded, and it will be posted at our YouTube site. And if we go back to our website, the main page, right down here below Connect with Us, you'll see links to various ways to connect: Facebook, Twitter, LinkedIn, WordPress blog, email listserv, and then also YouTube. And if you click on the YouTube option there, you can see this posted. Somebody asks, is there elevation data for Vermont? Yes, there is. If we go back to data and imagery, type in elevation. Kind of depends what you mean by elevation data. We've got contours of various types. The 2-foot contours that you see listed here, CN2T, are only available for parts of most of Chittenden County, not quite all of Chittenden County. The others are available the 10-foot also are only for Chittenden County. The 100, 20, and 50 are statewide. We also have what's called DEM data, digital elevation model, a few different sources. We also have a layer that just includes areas that are over 2,500 feet in elevation. We have some hillshade data, which is a raster data set that gives a sort of a faux hillshade look. And then we have slope data, which is generated from some of that DEM data. So there's a few different options here. We also do have LiDAR data available for parts of the state, not the whole state yet, but for significant chunks of the state. So if you know how to deal with LiDAR data, we have that. It's a little bit of a hodgepodge of formats for the different areas of the state. We are currently working on creating some more consistent derivatives like contours from that data. That's still in process. Okay. Okay. Great. Sounds like some people got something out of this. I'm glad to see that, especially since there were people who probably didn't need the GIS refresher. But thank you, everybody, for participating. Like I said, I welcome feedback and particularly any ideas about future webinars, and I hope everybody has a great day, the rest of your day.